The official Firecrawl connector for Claude has now been released, giving Claude a more accurate web search that can search through GitHub PRs, GitHub issues, project-specific readmes, as well as search and read through 40 million different research papers from biomedical and computer science, mathematics, and much more, which Claude's default web search tool just can't do. So let's go through how this works. And guys, if you like these type of videos, be sure to like this video and subscribe to the channel. It really does help. Now, before I go through how to set up the Firecrawl Claude connector, let me show you exactly why it's better than the default Claude web search. So here is the Claude desktop app for Mac, and I already have Firecrawl installed, which you can see over here. So I'm going to give Claude a prompt to tell me about a paper for DeepSeek's new harness plugin system. And I'm going to let Claude do a search. So now we can see it's using Firecrawl to search the web, and it's inspecting the paper. And now it's giving me information about the paper with a link to it down here if I wanted to view it. Now, if we scroll up to see everything it did, we can click the websites it visited to get the information, as well as the paper it found and the information it got from that paper. If I give the exact same prompt to Claude without using Firecrawl, so we can see here it did a regular Claude web search and went through 9 results, we can see that it also gives me some information, but it doesn't give me a link to the paper. And if we look at the places of research, it's pretty much popular blog posts, nothing from GitHub or archive, which means I'll have to give it another prompt for it to read the actual paper. Let's go through another example. So here's a different prompt I've given to Claude to go through this repo and find any information about breaking changes if I upgrade. So first, it tried to use Claude's web search to go through GitHub, and it wasn't able to fetch any of the results. Then later on in the process, it decided to use Firecrawl. It's a bit small to see, but it was able to get information from GitHub, which it used for its research. And in the final response, it's given me a list of things that will break if I upgrade, as well as more information about the problematic functions and methods. But if you focus on the bottom line, we can see it gives us information about what would happen if this command would run, and it tells us the exact problems with WGPU if we upgrade, so this get mapped range function, and also the specific issues in these files. I also ran the exact same prompt using Claude without Firecrawl. Again, we can see it failed to fetch certain GitHub links, but it was able to get others. And it also got information from a lot of non-GitHub pages that we can see over here. Even after all of that, it was able to surface some useful information about dependencies that will be fine if I upgrade. And it also pointed out this Rust crate, which will be a problem if I do upgrade, as well as Electrobron, which Firecrawl did mention, but it also mentioned that the pinned version is the latest, so an upgrade wouldn't change it. But the thing to point out here is the bottom line from the Claude version, which didn't specify the exact issues with WGPU, which means I'd have to run a follow-up prompt to find those issues, but Firecrawl was able to surface them because it went through GitHub. Now to set up the connector, go to Plus, Connectors, Add Connector, Browse Connectors, then we'll search for Firecrawl, and we can find the connector here to add, or we could also go to our settings, click Add over here, then Browse Connectors, and also search for Firecrawl, which will bring us to this page again. Now, if we click to connect to Claude, this will open up our browser for us to authenticate our Firecrawl account. And if you don't see the screen, then you'll have to create a Firecrawl account, which won't take too long, and then we can authorize the connector. Now, the benefit of installing the Firecrawl connector is that not only has it been connected in the Claude desktop app, it's also connected in the Claude web app, Claude Code under MCP servers, and also the Claude mobile app. So how is Firecrawl able to be so accurate where the default Claude web tool fails? Well, it's down to 2 things. The first is that web search was designed for humans and not for agents. So when Claude does a regular web search, it uses a general web index, which ranks pages based on SEO signals. So a blog post optimized for SEO will be ranked much higher than a changelog or release notes. But Firecrawl doesn't work like that. Because GitHub links and research papers barely have any SEO surface, they'll always lose in the ranking contests. That's why Firecrawl has indexed millions of research papers containing abstracts, metadata, and the body of the paper themselves, as well as loads of GitHub PRs, issues, readmes, and much more, which means based on your search query, the agent will direct Firecrawl to get information from its relevant sources, giving you more accurate results. Firecrawl has another huge benefit, which is its scrape cache. a huge database containing scraped information from loads of pages all over the internet, which Firecrawl uses to extract excerpts based on your search query, meaning it doesn't have to do a follow-up fetch, which is what Claude Code does. So you can see from here, it's done a search, or maybe a search over here, and it's had to do a separate fetch to get the information, which in this case it failed. But Firecrawl doesn't have to do that, because just by doing a search, it brings back relevant information from the page all in one call, not in two separate ones. So now you know exactly how the Firecrawl Claude connector gets you more accurate web search. Why not sign up for free? And if you do, you can use this code to get 500 extra credits. Finally, if you want to see how I use the official Firecrawl Convex component to create an app that can search and scrape developer documentation straight to a Convex database, then check out the next video.